In this video, we are going to discuss about sorting and ranking. Sorting and ranking are essential operations to organize data and analyze data in Pandas. We have two ways of sorting the elements. One is sorting by index and the other one is sorting by values. And sort underscore index is the method that is being used to sort either by row or column labels. And if you don't mention any specific order, the elements are going to be sorted in the ascending order by default. And there is another way of sorting the elements, which is sorting by values, wherein you can sort the elements by using the corresponding row or column, and the corresponding method that is being used is sort underscore values. And if you don't mention any specific position for NaN, the NaN values are going to be placed at the end by default. Let us see using an example. In this example, we are creating a series object, and let us see how to sort the elements of the series by using the index. So the corresponding series that is being created is having the elements 0, 1, 2, 3 and with the index mentioned as D, A, B, C. So if you apply sort underscore index by using obj.sort underscore index, the index is going to be sorted in the alphabetical order, or if it is numeric, it is going to be arranged in the ascending order with the corresponding elements rearranged. Now let us look at sorting of a data frame. Here we are creating a data frame by using the method pd.dataframe, and the shape of the data frame is 2 by 4 with the index 3 and 1 and the column labels as D, A, B and C. So this is the corresponding data frame that is being created. Now when we apply frame dot sort underscore index, the elements are going to be sorted based on the index. Here the index is 3 and 1. So elements will be sorted in the order of their index. So if you look at it, is not the index is not numeric, it is a string. That is why it is going to be arranged in the form of a dictionary. So as 1 appears in the dictionary first as compared to 3, the index is arranged so. And the elements are also accordingly arranged. Because 1 in the index 1 we have the elements 4, 5, 6, 7, and so in the result also we'll be having the same set of elements corresponding to the index 1. And similarly we have 0, 1, 2, 3 corresponding to the index 3. That is why after sorting by index we will also be having the same set of elements for the index 3. Now let us look at one more statement, which is frame dot sort underscore index axis equal to 1. So what is the meaning of axis equal to 1? It is horizontally along x-axis. So what is existing horizontally along x-axis? It is nothing but the column labels. So the column labels will be arranged in the order of in the ascending order, but if you use axis equal to 1. Now let us look at the output. So whenever you say axis equal to 1, the column labels are arranged in the ascending order. So A, B, C, D. And correspondingly, the elements also will be reorganized. And the next one is sort underscore index axis equal to 0 and ascending equal to false. So here you pause for a while and think what is the corresponding output. So when you say axis equal to 0, the meaning is vertically along y-axis. That means vertically means we have only the index which is 3 and 1. So if you say ascending equal to false, the elements are going to be arranged in the descending order. So what is the descending order? 3 followed by 1. So there won't be any change in the data frame when you apply sort index with axis equal to 0 and ascending equal to false. So this is the corresponding output. 3, 1, D, A, B, C. There is no change across the columns, but as these index 3 and 1 are already in the descending order. That is why there won't be any change. Now, when you say frame dot sort index axis equal to 1 and ascending equal to false, here the labels of the columns are going to be considered for sorting, which are nothing but DABC, which will be now rearranged in the descending order, which results in this particular data frame where we have the column labels D, C, B, A and 3 and 1. So this is how the sort underscore index can be applied both on series as well as data frame objects. Next, let us see sorting by values. So this sort by values is used if you don't want to represent any column labels or index, but instead you want to sort the elements based on the values that are present in the series or data frame. So in such a case, you can use sort underscore values, but here the missing value NaN will be placed at the end of the result by default. And you can also handle the position of the NaN by using Na underscore position. Let us see how. So for this we are creating a series object with NaN value. So in the series we have np.nan 7 minus 3 and 2 and the corresponding index is 0, 1, 2, 3. So if you say obj dot sort underscore values, the elements are going to be sorted and so the index also will be rearranged accordingly. So here if you look at the ascending order minus 3, 2 and 7. Since the NaN values are placed at the end, we got this result. And specifically, you can also mention the position by using Na underscore position equal to first. If you don't want NaN to appear at the end and if you want to appear NaN at the beginning, so you can do so by mentioning Na underscore position equal to first. So if you give that parameter, then the elements will be sorted by placing NaN in the first position. And now let us see sorting by values in a data frame. So for that we are creating a data frame by using frame equal to pd dot data frame. We are using a dictionary wherein the keys p which are b and a which are nothing but the column labels and with the elements 4 7 minus 3 2 under b and 0 1 0 1 under a. So here since we didn't mention any index, it is going to consider the default index which is a 0 1 2 3. Now, if you apply frame dot sort underscore values of B, it is going to sort the data frame based on the values under the column B. So since we have uh, the elements 4, 7, minus 3 to under the column B, the elements will be arranged in the ascending order. So minus 3, 2, 4 and 7. And accordingly, the elements of A and the index will be rearranged. Now, you can also mention two columns. You can also mention two columns for sort underscore values. So here you can pass A and B. So here the order of the column labels matter. That means it is going to sort the values initially based on the value of values under the column A, and if there is a match in the elements of A, then it is going to look at the elements of B for sorting the rows. So let us look at it. So here the elements are sorted first in the order of A, and if there are multiple elements under A having the same value, in such a case then it is going to look at the value under the column B. So minus 3 and 4 where the value of A is 0, and similarly 2 and 7 where the value is 1 for A. So here basically the primary column label that is going to be considered is A, and if there are duplicates for A, then it is going to look at the value under the column B for sorting. So as it is, the column B is not sorted, but if you look at the labels A, whatever the elements corresponding to 0 under A will be sorted. So minus 3 and 4 are sorted whenever A value is 0, and the elements 2 and 7 are in the sorted order whenever the value under A is 1. But if you look at the entire column, it may or may not be sorted, right? Now let us look at ranking. So ranking is used for assigning numeric ranks to data points based on their values. So we can also choose whenever there is uh, repeated values. In that case, the ranking uh, can be given as per the method that you choose. So if you give method equal to average, wherever there is a tie, the rank average of the ranks is going to be assigned for the ties. Similarly, we have method equal to minimum, method equal to maximum, method equal to first, and method equal to dense. So let us see how this ranking works on a series object. So let us consider a series object with the value 7 minus 5, 7, 4, 2, 0, 4. So if you try to give the ranking, it is going to give the ranks based on the order of the elements in the ascending order. So in this case, minus 5 is the least element. So the rank 1 is given to minus 5. So we have 1.0 in the result. So if you apply obj.rank, that means we are applying the rank method on the series to rank each and every element. Let us suppose you have a set of CGPA scores based on which you want to rank the students. In such a case, you can pass the list of CGPAs to the series object and you can apply obj.rank so that you will be getting the students which are ranked with the corresponding rank based on their CGPAs. So let us look at minus 5, which is index 1, it is given the first rank. Then 0, which is given the second rank here. And the next highest element is 2, 2 which is given the third rank. And then we have 4. But here if you look at it, 4 is existing twice. 4 is existing twice and we are supposed to give the rank 4 or 5 to these two. So average, by default it is going to consider method equal to average. That is why the elements 4 are given the rank 4.5, average of 4 and 5. And similarly, there are the next highest element is 7, which is appearing at the 0th index and index 2. Here we are supposed to give the rank 6 or 7. So the average of 6 and 7 will be considered for giving the rank to the elements. So that is why we have 6.5 at 0 and second position. So if you mention ascending equal to false, the elements are considered in the descending order for giving the rank. So you can try by passing the parameter ascending equal to false and observe the output. And you can also try by mentioning different methods of assigning the ranks. Method equal to minimum, method equal to maximum, and try to observe the outputs by mentioning the different methods. So if you mention ascending equal to false, the element 7, which is appearing at 0th and second position, is given the rank 1.5 because we are supposed to give 1 and 2 for these two elements since there is a tie because both the values are same. It is going to give the rank 1.5 wherever there is 7, and subsequently all other ranks are modified based on the decreasing order of the elements. Now let us look at ranking in data frames. For that we are creating a data frame. Here the columns are B, A and C. As such, we didn't mention any index. That is why it is going to consider the default index 0, 1, 2, 3. And if you apply frame.rank, here axis equal to columns. So axis equal to columns means it is going to give the ranking for the rows. So remember, axis equal to columns and axis equal to 1 both are same. To avoid confusion, so far I didn't use axis equal to columns. You also try to use only two values for the axis, axis equal to 0 and axis equal to 1. So the meaning of axis equal to columns is axis equal to 1, which means horizontally along x-axis. That is why the elements are arranged across the elements are given the ranks across the rows. So if you look at the first row of elements at the index 0, we have 4.3 for column B, 0 for column A and -2 for column C. Since -2 is the least, it is given the first rank, then 0 is given the second rank and 4.3 is given the third rank. Try to write the data frame and observe the ranks for the subsequent rows. Because in the second row we have the element 7, 1, 5. Since 1 is having the least value, it is given the rank 1, and then 5 is given second rank and 7 is given the third rank, so on and so forth.